Welcome to Study Loop.
In our question, we are told that A, at what upstream angle must the swimmer in problem 67 aim if she is to arrive at a point directly across the stream? And B, how long will it take her? So I wrote out here what we were given, and we're given that the velocity of the water relative to the bank, I write as V sub W, is equal to 0.50 meters per second. And the velocity of the swimmer relative to the bank is also 0.60 meters, or is 0.60 meters per second. Okay. And then I drew out the diagram here of what was in problem 67. You have the direction of the velocity of the water. You also have Vs prime, which is the velocity of the swimmer relative to the bank. And then I'll go ahead and draw in the bank here as green. So you have the bank on either side here is green. Okay. And then you also have V of S, which is the actual velocity of the swimmer trying to swim from one direction to the other direction perpendicular to the bank. Okay, so we know V of S prime, we know V of W. And then for A, it wants to know the angle theta that we have here. Okay, well, we can use our trigonometric identity that the sine of theta, sine is opposite over hypotenuse. So sine of theta is going to be equal to the opposite, which is V of W, divided by the hypotenuse, which is V of S prime. Okay. And then to get theta, we want to solve for theta. So this is part A, actually. Let's indicate that this is part A. We want to solve for theta. Theta is equal to the inverse sine, which is sine to the minus 1, of VW over Vs prime. And we'll just go ahead and write what VW is, which is 0.50 meters per second. And that's going to be divided by Vs prime, which is 0.60 meters per second. The meters per second cancel, so we don't have to write those. If you take the inverse sine of that ratio there, you will get 56.44 degrees. Which, let's report to the correct number of significant digits, is approximately 56 degrees. So that is our solution to part A. Now, part B wants us to find how long it's going to take her to transverse from one bank to the other. Well, we are also, I didn't write this down, but let's go ahead and indicate it now. The distance between the two banks, let's call that D, is equal to 55 meters. So we want to figure out the time it's going to take her to transverse this entire thing. Well, let's get a new page going here. This is part B. Distance is equal to the velocity times the time. And this velocity is going to be the velocity in V of S. This is going to be V of S. Okay, so the time, which is what we're trying to find, is going to be equal to D divided by V of S, which is going to be equal to 55 meters divided by V of S. Well, that's going to be V of S prime times the cosine of the angle. That's V of S prime times cosine of theta. Okay, well, we know what V of S prime is, and we found theta last time, so that's going to be 55 meters divided by V of S prime, which is 0.60 meters per second. Times cosine, and then the angle we found was about 56 degrees, but it was 56.44 exactly, or approximately 56 degrees. So we'll just write 56.44 degrees. And all of that is under that in the denominator. Okay, so if we plug all of this into our calculator, we find that this equals 170 seconds. 170 seconds, which in minutes is equal to 2.8 minutes, because there are 60 seconds in every minute, so you just divide that by 60 to get it into minutes. Okay, and box that in as our solution to part B.